All right, let's kick it off. In-building wireless, deep dive was the actual title of in-building wireless, and we are going to do a light dive, a shallow dive, if you will, into in-building wireless, and then we're going to see where in-building wireless fits into the scheme of things for IoT, because really the subject of this whole summit really is IoT in the enterprise, and so that's something I'd like to address from a wireless and also from a structured wiring perspective. We'll start, I'll do a quick intro on who I am, who Extenet is. We'll talk about distributed in-building networks. They're generic structured wiring type networks. In-building IoT. Then we're going to talk how the network is core. This layer one thing is absolutely needs to be there. We need to take care of it. Then leveraging big data. We're going to go through just a couple of high level on a use case, and we're going to look a little bit deeper into one just to see how IoT fits within the structured wiring. And then we've got a set of IoT trends and then a summary in the end. So, and I invite you to ask questions at your leisure. Raise your hand, throw something at me to get my attention, and we'd be happy to reflect the questions, or even if you want to wait to the end. And I've got an hour. This will not take an hour, so don't worry. You'll make all of your appointments and your flights. Extenet Systems, we're the leading independent provider of distributed networks systems, DNS we call it for short. So you'll learn later the DNS really includes lots of stuff, everything from a distributed antenna system, really where Extenet started in our business, right up through facilitating any sort of structured wiring, fiber to copper, and the integration of that. I've been with the company 8 years. Russell Vest's my name. I've come out of the telecom background with a lot of work in wireless, been in the business over 30 years. So, excuse me, I've got an engineering background, but I've tried to sort of learn not to be an engineer many times. It does occasionally get in the way. So please let me know if it's getting in the way this time. Let's talk about these distributed networks. First off, and to have these distributed networks indoor, it increases the value of your property. This is very good for large landowners. It's good for basically all the verticals that have physical bricked property. We all know that about 80% of the mobile traffic is generated indoors, and of course, without an indoor network, that mobile traffic may not be generated. And then just a couple of other bullet points on the viability of these networks. Also, because it's a structured wiring network, it uses, or it can support any IoT use case, any of them that are out there. And then, of course, all of the mobile communication standards, fixed broadband, producing gigabit, okay, right to the tenant or right to the service user, public safety, emergency services, first responders. It's all part of the IT infrastructure, so it supports everything that we've talked about over the past 2 days here at the summit. And this has been referred to a number of times by others as the fourth utility, and indeed it is the fourth utility. So we add that to electric power, water, sewer, all those kind of things that a building needs. Just a couple of points on the various kinds of things the network supports. We're asking the network to support various kinds of tenant services that can be resold or as part of the package, from high-speed internet, wireless, interactive media. We've got cloud services, and then a private cloud network. And then we have what the building needs are, largely building automation type systems, lighting, signage, elevators, security, HVAC, fire control, and energy management. So all these things are really supported by one convolved infrastructure of cabling and wiring. Indoors, right? We got to build this thing indoors. So just let's look real quick at the market size. There's about 25 billion square feet in the U.S. Okay, so that's a lot of square feet. All right, and then we have a pyramid here, which is kind of showing the high-level properties, say greater than 1 million square feet, right down to the smaller properties. And from a infrastructure standpoint, the big prime Class A real estate, the arenas, the subways, public spaces, airports, those are all designed in many cases with the original thought of supporting all these services that I mentioned on the previous slide on some sort of infrastructure. earlier versions of this, because the various services came out at various times, usually you'll have separate infrastructures for each one of these. If we're building new, we'll want to build it onto a converged infrastructure, largely a large optical fiber backbone. As we go down the chain, we see applications using smaller piecemeal type services, disparate networks that aren't connected. As time goes on, we're going to need to tie those together from a management standpoint, from an operations standpoint, and from a security standpoint, so that we can control all of those things essentially from one desktop. There's a lot to do. All these buildings, all the different sizes, who pays for it, we've got all those things to solve. These are some of Extenet's networks that we have, and we're sort of covering the gamut from healthcare to Circuit of the Americas, which is here in Austin. Great place to go see Formula One racing here in the U.S. We've got the Empire State Building, Barclays Center, Marlins Park, Bankers Life Fieldhouse, the Kennedy Center, AT&T Stadium up in Dallas. So there's a number of these networks that we have up and operating indoor throughout the U.S. These are some of the hallmark ones. And these are the places where we either build, own, and operate, or build and manage the structured wiring network to support cellular, in many cases Wi-Fi, IT services. In AT&T Stadium, for instance, we support the NFL, we support the teams, all the needs, game day needs that are required for NFL type things, play review, which all happens in New York, so all that has to be fed back. So all those things that we manage on the same converged infrastructure. Clearly the direction we need to go to support the needs of IoT. IoT is all these things, these Internet of Things, all these sensors and devices that are out there, and somehow they all need to talk to the Internet at some point, or at least they need to talk to the edge computing device to decide what needs to go to the cloud or the Internet. We've got technology that's being enabled by that's enabling the growth of IoT, starting with sensor devices and mobile phones, sensor devices. We've seen, in fact, here on the show floor, we've seen a number of different sensor devices to go into and to become part of this Internet of Things set of devices that still need to talk somehow to a master controller up in outer space somewhere. In other words, we got to get this information back in one way or another. And that leads on to how do we get it back, which is the networks and communications. So we have cellular, Bluetooth, we have Bluetooth low energy, and then we also have a dense optical fiber layout. So all of these things convolve together, and we're able to support IoT, the growth of IoT. We have to also decide what's going on, and that's done with compute and storage and compute at the edge to some degree, and then storage and compute at a cloud layer level to make decisions, to look at prescriptive directions, and for the next step, really, which is big data analytics, to make decisions on how we can run our business better. And we're sending that about Cisco says we're sending about 2 exabytes a day to big data. We're collecting that worldwide today. In 2000, I believe their stats say we collected, up to the year 2000, we collected the same. So in other words, in 2,000 years roughly, we collected 2 exabytes, and now we're doing it 2 exabytes a day. So I don't see that acceleration rate changing dramatically. Oh, and this is from a study from the IEEE study of IoT things. It was done back in 2014. Well, there's a lot of standards. This is so confusing. We have all these different standards, delivery mechanisms, networks. Some networks are there, some are proposing to be there, some are partially there. It's crazy. And then this is the early stage of IoT. It's the early stage of 5G. So this is the sort of the area where we're trying to get market adoption on some of these standards, and to date we really don't have a clear way forward. We have a bunch of disparate mechanisms to communicate both wirelessly, wired, and I'm not even addressing the scripts and the actual language of the sensor devices themselves, which was discussed in other sessions, which is actually inherent with the device. There's scripting, there's the ability to change the software set, to interrogate, and all those things which are separate from just the communication fabric, which is some of the standards I have in the background that falling out. But all of these things have to connect to a network. So the network is the mechanism, is the only way to get all of the information, okay, back to decision making. Somehow it has to get back to decision making. So we build networks, and we need to build networks, both indoor and outdoor, municipal networks. Optical fiber appears to be the best choice from now, so pull a lot and go dense with optical fiber. So it is the network, and to steal something from Cisco Systems, not steal actually, but to use something that has been used in a number of other similar presentations, we've got this network is the platform that supports everything from bring your own device to analytics, the sensors, the devices, detectors, the devices, detectors. We've got all sorts of expectations. We've got business transactions and globalization. All of these really go on the backbone core network. So the network really is what's connecting all the bits and pieces. This layer one thing that we sometimes don't pay much attention to, it's critical to not just IoT, but to the rest of us in the communications and in life, not just the communications industry, but in life. So previously we had kind of separate silos. We had operational technology and information technology. And those were two really separate, not quite siloed, but they didn't cross over much. They had all these functionalities from, on the operational side, from telemetry and Wi-Fi to on the information side. Then you've got all the operations, the ERP systems, CRM and whatnot that happen within, say, an enterprise environment. So convolving those or getting those onto the same structure gives you one clean structure for everything from wireless, whether it be cellular, whether it be IoT, all right through to ERP systems, managing systems, industrial compliance. PCI was mentioned in the previous set. So all of these things are now are converged onto one infrastructure, and that's a really key operational and management savings. So there are 5 requirements really for a successful IoT implementation. And they revolve around the network. So it has to be a converged, manageable network. It has to be resilient at scale. So as we build this thing out, it has to be able to heal itself, fix itself, tell us where there are problems. It has to be secure, which a number of sessions have brought up security as a super important issue. And we all value our credit cards and try to keep them in our pockets. But when we do scan them, sometimes things aren't happy. Then we have to distribute the intelligence. We've heard a couple presentations of moving the intelligence out to the edge or closer to the edge. We need to distribute that out to improve latency, to not require so much backhaul transport for all these sensor devices. And then we have to have the applications that not only work for us in use cases, but work for us as people. So it has to work in the use case, whether it be a business or a person. It has to be something that we can actually exercise and enable. And it's not too terribly hard to use, I hope. Let's look at some big data collection. This is not just indoor, okay, just to point this out, but there's 46 million smart meters in the US. There's one single consumer packaged good machine generates 13 billion data samples a day. I mean, this just happens all the time. We've got offshore oil fields that produce 3/4 of a terabyte. We've got 10 terabytes for every 30 minutes of flight with 25,000 flights a day. So that's how we're getting to our 2 exabytes a day. Going back, remember, from, say, the Roman time to 2000, back when I was a kid in the Roman times, to 2000, we got to 2 exabytes over that entire period, and now we're doing that every day. It's crazy. Absolutely crazy. What we do need to do, though, is now we got all this 2 exabytes of data coming in, and we got to take the data and we got to turn it into knowledge. Somehow we have to turn it into knowledge. And so we do that with descriptive analytics. We open up, we try to figure out, okay, we're measuring this information, so what's happened? I got all this stuff in, we got to figure out what has happened. And then once we sort out what's happened, we have to figure out what the next thing is or what could happen. Okay, so that helps us be ready for the future if something good or bad happens. It helps us to be able to run our businesses better because now we can describe what we want to do in the future to some degree. So prescriptive analytics, we carry this forward to what we should do. What is our next move to get a positive outcome? So these are all key things, okay, to make the decision to what we need to know and what we need to base our knowledge on, given we've got 2 exabytes of data coming into our house. And when I say our house, I mean our data collection facility, not our personal house, but I know my house is putting out a lot of data right now. Let's look at a couple of IoT use cases at a very high level. We know there's healthcare, which has been brought out earlier. There's hospitality, industrial. The industrial is probably the first real user of IoT because of the density of sensors they've had in the industrial manufacturing complexes. Retail, malls, all kinds of applications in retail malls, and sports and entertainment. So we have all of these different use cases that fall into these verticals, okay? And the use cases can be more building automation or building centric. So here's a description of a smart building that is using sensors and control devices, everything from HVAC, security, safety, all the utilities, environmental management systems, even wearables, as we're walking about with wearables in our clothes or on our arms, lighting, information displays. So all this is going on sort of in the operations side. But what about us on say, the user side, you and me? And let's look at that from a hospitality standpoint, because we've already kind of discussed we've got this machine, this building that's operating. We want to keep it operating. We want to keep it efficient. But then we also have another side of IoT, and it really is, in the hospitality sense, guest-facing. And I chose hospitality because I've done the most work of this with HT&G, the Hotel Technology Next Generation Group. And what we came up with is these use cases that are all guest-facing. And guess what? Because they design hotels to look a lot and feel a lot like your home, the closer they can get to your home, the more comfortable that you are. At least that's the theory. This is just like what you need at home. So you've got everything from security to basically value-added services that, from a hospitality standpoint, can generate additional revenue. Lighting automation. There's a Wi-Fi access point most of the time. If it's not in the hall, it's in your room. You've got an IP phone. You've got the mobile panel. You've got the ability to take your display device and have that come up on the big screen. So you have all these capabilities that are really guest-facing functionality and part of IoT. So the IoT is not only the operations side, but it's also the user-friendliness, how do we make more money, all those kind of things side too. So in each one of the verticals, we have a very, very similar array of operational and people type facilities for IoT. And that's really why I wanted to point out this about hospitality. There are IoT networks out there today. There are IoT capable networks today. And in fact, we see Verizon here at the conference over the past couple of days. And so if we were to say we wanted to roll out an IoT facility, the easiest way to do that today may be to use what the carriers have spent so much money and so much time building so that our phones work, essentially. And so they're doing some great things in low power. These are trends, okay, that are predicted for 2017. So this low power wireless access goes mainstream. You've seen probably in the press about the carriers coming out with low power devices, not as high power as a smartphone, but low power devices that can even do some even do some energy harvesting. Okay, that's how low power they are. They also don't tie up a lot of bandwidth. So this opens the door for a plethora of more devices, sensors, machine-to-machine type devices to be out in the network and to be corrected, to be connected, and then to correctly associate themselves with the network. Security becomes a priority. This is another one of the key predictions for 2017. We've seen security breaches, they scare us all, and yet the more open and the more pervasive we make the network, it seems the more open it is to breaches. So that's another one that will come in 2017. The MSOs, the mobile system operators, were also TAP developers. We're already seeing that. Verizon here has APIs that they're interfacing to. They're offering it to their subscribers today for IoT type applications. So they're getting into this in a really serious and a big way, and they should. I mean, they've got the network; they might as well expand it. And I think there's another revenue stream there that they can extract. They have to also learn about machine learning. Okay, so this IoT data will be brought in and rationalized as knowledge, and then they will be able to process and analyze it, make their services better, more intelligent, hopefully more cost efficient as well. And then the fifth, and this all came out of Rethink, came out of Ovum out of the UK, just to point that out, is the business service model. So now we know, going back to the slide of predicting the future, now we have some information that we can actually use to drive a business model. And these will be transformative business models that will move and shape based on the information that they receive. So applying that knowledge to the new business is a key and a really powerful thing that the carriers can provide in short order, mostly because they already have the network. Well, here we are at summary. I told you this wasn't going to last an hour. Okay, so everybody's still awake. I see. That's good. Just point out, IoT is real today, and I want to say it's real because it's available. The technology is basically there, but as we saw, it has issues. It's got multiple protocols that aren't sorted out yet. It's got multiple protocols both on the interface side, the access side, but also in the application side, trying to talk to these devices, trying to collect them. So it's a huge growth segment, and that's just, that's something that's inevitable by virtue of this summit being here, if nothing else. Okay, we all came here for a reason, and IoT is key to that reason. The underlying infrastructure, and I've mentioned this a few times, the structured wiring right down to the wireless network, the infrastructure is king here. If you don't have a way to connect the device back into its machine learning and all its other capabilities, the data is lost. It can be stored for a while, but if it can't send the information back to be deciphered, to be decided on, it's lost. So the underlying infrastructure is key. There are so many use cases, we can hardly go through them. I just touched on the verticals, but again, within each vertical, you've got operations and you've got people-facing use cases. Big data must be leveraged. We've got to turn big data to knowledge. That's another key thing that's happening, and we're seeing that evolve and come together, particularly at this summit. Momentum is building, and it's a real driver for 5G. Going back to what the carriers have installed today, they spent billions of dollars worldwide. They've paid some of their countries, I know in the U.S.'s case, they've paid the U.S. government a lot of money for licenses in these bands, and then our U.S. government promptly went and spent it all. At any rate, there's still more frequency that they can farm and sell and get more revenue. That's great. But there's a huge investment in network. And so changing that to 5G, going to the different frequency bands of 5G to address really high bandwidth, short distance type applications at 28 gig, at 60 gig. So all of these things are coming along with 5G, and to make it a more ubiquitous, user-friendly environment, not just for us, but for machines. And I believe that's it. So entertain any questions. Yes, Monica?
3.5 CBRS, do you think is going to help IoT, and if so, how?
Absolutely it will. It's a bit of a hard question to answer just straight up without backing up and looking at CBRS and where it is today. We can't call it a mature technology, or we can't call it a mature service at this point. Technology is kind of irrelevant. All we're doing is we're changing frequency bands and things like that. It's going to be LTE likely. We don't have any low power applications in 3.5 or in CBRS at this point. So that still hasn't evolved from a sensor standpoint, being able to do low power. The key thing about CBRS, if all these pieces come together, and we're a part of Multifire and also the WIN Alliance, the key thing is it enables the enterprise or the venue to control their destiny from a wireless standpoint, because they don't have to rely on one of the four, or maybe the lesser, there's maybe 5 U.S. cellular carriers. They don't have to rely on the cellular carriers to bless, install, or pay for a network indoor. So having 3.5, you could akin it very much to having having a Wi-Fi network. Today we can use 5 gig pretty well. We're going to crowd that out. But using 3.5 in the 3.5 radio transceiver looks a lot like a Wi-Fi access point. So once we get to that stage, we're working there now. We're working with several vendors and trying to roll that into a neutral host type solution. And the neutral host in that case is instead of indoor, typically we have 4 carriers. We have 4 different strings of equipment. In a neutral host environment, you have 4 different transceivers. Each carrier has their own transceiver fed into this network, this common network. In a CBRS standpoint, you don't need the 4. You can have one radio transceiver, essentially, rather broadband, and you can handle and talk to all of the carriers and hand off all your carrier prescripts to each one. Now, that requires the carriers to embrace this. And at this point, they haven't. They're in process. They're part of the 2 alliances I just mentioned. They're very involved in it. We're having meetings with the carriers are our customers today, and so the wireless carriers. And so we're having meetings with them, very active meetings with them now. But if you look at it from their perspective, they're kind of opening up their core network a little bit, okay? Because we've got to hand people in and out, okay? So that the use case is easy. Right now, if you use Wi-Fi, for instance, and you walk into a building, you have to reassociate, okay, with Wi-Fi just about every time. Hospitality's made that easier. Hotspot 2.0 has made that easier. But in CBRS, the idea is you would just roam onto the CBRS network, okay? And to do that requires some pretty dense connections at the core with each carrier, and that, as yet, really hasn't been embraced.
But I think it's interesting because, as you point out, the enterprise can take a more active role.
Oh, yes.
And so if you have a neutral host, they can have a neutral host, well, not really neutral host, but they can deploy their own IoT applications, and then the network is there, and if the mobile operators want to come in and use it as on a neutral host type of basis, they can.
Right.
But otherwise, and so IoT and general public access to operators can coexist in the same network. So that's also potentially interesting in terms of business case.
Right, and I failed to actually mention your question. I was asked to, and I failed to do that. Hopefully the reader or the people that watch this later can figure it out. We were talking about CBRS at 3.5 gigahertz being, as a secondary user, being a licensed free band that can be used for indoor wireless and even outdoor to some degree, but mostly indoor wireless. And Monica brought up the point that from an IoT standpoint, it's a band that's pretty much readily available that you could do as long as you meet the requirements of being the secondary user, which those are kind of built into the CBRS, the current regs in their current state of forming. So I think there's lots of opportunity for IoT to use 3.5. First real application in a mobile environment is going to be later this year. Right now, most everything is trials with beta equipment and things like that. We're involved in some of those things. But I absolutely agree with you and think it would be a huge relief to be able to use 3.5 for IoT devices, particularly if you could think of like a huge industrial complex or something like that where you own it, and that way you can control it. Your own IT department can manage it.
And it gives you a little bit more control over the network than Wi-Fi would be.
Yes. Control over the network.
Comparable costs.
Yeah, and you're not reliant on the cell carriers in those cases, the mobile carriers, right. So those are all compelling. I totally agree with you. And that's one reason why we're very involved, actually, in the CBRS type business opportunities. Are there any other questions? Yes?
You put a slide up there that was a pyramid showing the addressable market in commercial real estate.
Yeah.
As you move down that pyramid, do you notice a market education problem? And if so, how does that impact your typical sales cycle?
Okay, so the question was, on slide, I don't have my slides numbered here, but there's a triangle on one of the slides that talks about the in-building market size. And the question was, is it harder to get people to realize a network is required on the smaller square footprint buildings than it is the larger ones. Is that fair? Okay. Yes, it is hard. The nice thing as you go down to the smaller venues or smaller buildings is a lot of them are run by a core group of people, or maybe even by one person that makes the decision, which can make that move really, really fast. Okay. The problem is there's a lot of them. And so it's really hard to get to all of them. And then the investment required to have a full wireless network within your building when you're only 50,000 square feet or so is pretty high. And so getting an ROI, or looking at the IRR, okay, of that investment over time, is sometimes a little bit difficult to get over. Some people, it's mission critical. Okay, it's absolutely necessary. And so in those cases, the decisions are pretty fast. And usually those are single enterprise entities, building a home office of a company, maybe a US-based company that's not huge, is a good example where it's mission critical. Everyone, their phones have to work, all the IoT devices have to work. But then as you get more decision makers as part of that process, it tends to draw out the sales cycle or the closure on the property, cycle from a real estate standpoint. So sales cycles are anywhere from to get a carrier on a venue, let's say a large venue. If it's a marquee venue, if it's AT&T Stadium, the carriers know they have to be there. The IoT bits and pieces, the NFL stuff has to still work. All those things have to work. So it moves pretty quickly. If you look at, say, a suburban office building that has 50 tenants, it's hard. It takes a lot longer, not only to convince the management that something needs to be done, or the management to cough up the money to do something, because then they've got to increase rents, and they still want to be this tech-friendly building, right, to attract the right tenants. It's still something that is new and that isn't totally embraced by a lot of owners, by a lot of building owners. It's a challenge. It's a good point. Yeah.
Another one, if that's okay.
Yeah, fire away. Yeah.
Extenet, from my perspective, it seems like you guys have gone very aggressively after healthcare, which is a lot of hesitancy around that. Have you guys encountered any sort of problems? And I'm speaking specifically with the nature of the data that you're transporting here. Is there any sort of exposure to Extenet and handling that?
No, and it's actually a broad, okay, I'm sorry, I'm supposed to ask the question. In particular, at healthcare, and Extenet's handling of the data, I think that was the question, and the carefulness you have to handle the data, or the HIPAA rules and all those kind of things. Is Extenet, are we liable, or do we have a risk factor involved in that? Our current work in healthcare, all of our work in healthcare is with the wireless carriers. And so, in essence, we build a network that's a transport network. And that network essentially spreads the radio energy throughout the facility so that your phone works or the sensors work or any of those kind of things. All the data that comes over that network is encapsulated basically in a VPN created by the carrier. So Extenet doesn't have access to that. In fact, there's an FCC rule, a CPNR, I think is I'll have to cough up what it really means in a minute, but essentially where we can't use that data. We have to stay away from that data. And so there's no liability or risk on our side in that case. If we were doing a Wi-Fi network in a healthcare environment, that would be a different story, okay? Healthcare in particular, Wi-Fi is so central to the way they run their business, they really need to own that. That way they can control it, they can meet all the prescribed requirements, because they've got PCI, HIPAA, they've got all those things that they've got to meet. So no, we don't see it as, it's not an issue that we really have to encounter, but certainly the carriers do. And they do a good job of it too, because they're pretty risk averse. No more questions? Well, I want to thank all of you for coming and giving me a good reason to speak. And thank you so very much for staying awake and throwing something at me when I needed to stop. And I hope you have a great rest of the day. Go enjoy Austin. It's beautiful outside. Thank you.